Congratulations on hitting the end of this chapter. This chapter was all about pointers. And pointers are special kind of variables that store addresses to other variables. We had a chance to learn about this. We looked at how we can use pointer to characters to store text information properly and conveniently. And this was used to actually improve the design of how we store the data in our fortune teller application. And this was flexible in that we could store any amount of characters in our strings and we weren't wasting any data. We used just what we needed, not more, not less. And this was pretty cool. We also had a chance to look at the difference between const pointer and pointer to const. This is a subject that confuses many beginners, but now I hope you have this cleared in your mind and you're going to have this little rule to help you out if you get confused. If const shows up on the left of the star, the data is const, so you kind of have a pointer to const. You can't go through the pointer to modify what is pointed to. If the star shows up on the right of the star, then the pointer itself is const and you can't make it point somewhere else. This is really all this is about. And if you try to modify like we do here, you're going to get a compiler error. We then took a closer look at the relationship between pointers and arrays. And these two concepts are closely related in the C++ programming language. The name of the array can basically be treated as a pointer to the first element of the array. And we have seen that through the magic of pointer arithmetic, we could do all kinds of crazy things. We then took out an example of how we could swap array data. We showed you an convenient way of doing this by looping around multiple times and copying data basically slot by slot. And we showed you that we could actually do better by copying pointers, which was a really good operation in that the complexity of the operation wasn't increasing with the number of items that we had in the loop. And this was pretty cool. I hope you liked this. We then took a look at pointer arithmetic, which is a series of operations you can do on your pointers to make them move forward or backwards. We showed that we could subtract pointers to have the distance between elements. We saw that we could compare pointers. We could do all kinds of crazy things with pointer arithmetic. We then revisited our idea of the C++ program execution model, and we saw that our program actually thinks that it owns all the memory in the computer, and when it executes, the memory management unit in your CPU is going to transform the idea of the program in your C++ program to the real situation in the hardware memory in your computer. And this led to the birth of the idea of virtual memory. And the idea your program has of the memory is called the memory map. The memory map is split into different parts, and those that we are specifically interested in this course are the stack and the heap. And we saw that you could actually dynamically allocate memory from the heap using the new operator. And when you do something like this pointer is going to be pointing to dynamic memory that doesn't live on the stack, but that memory is going to live on the heap. And when you do that, you are responsible for releasing this memory. If you don't do that, you're going to leak memory, and that's a really bad thing. We then explored the concept of dangling pointers. These are bad pointers that don't contain a valid address. We showed that that could be a pointer that is not initialized properly. It could be a deleted pointer. This could also come as a result of multiple pointers pointing to the same memory, and we saw an example of that. We then saw that the new operator can actually fail, and we showed you different ways you can handle this problem. You could go through the exception mechanism, or you could do the std no throw setting on your new operator, and you would get a null pointer if the operation actually failed. And we showed you how you could use this in your C++ programs. We then explored the concept of null pointer safety. This is basically before you use a pointer, do check it against null pointer and see that you have something valid inside before you use it. After that, we learned about memory leaks, which is something really bad that happens when you lose access to a piece of memory that you dynamically allocated from the heap. And when that happens, your program is going to lose access to the heap memory, and the operating system thinks that you are still using the memory, so the memory is really being wasted. And if you overdo this, if you have a lot of memory leaks in your program, your program might be killed by the operating system because it is basically taking too much memory that isn't really using, and it's not returning that to the operating system. So the operating system is going to say, this is a bad program, I am going to kill it, and you're going to get a crash like we saw in this chapter. After all this, we also looked at dynamic arrays, and this is a way we showed you that you could dynamically allocate the array on the heap, and we showed you that this basically works like static arrays, but there are a few differences. Dynamic arrays don't work with std size, and they don't work with range-based for loops. This is really all we talked about in the chapter. I hope you found it interesting. Pointers are a really great tool in the C++ programming language, and you're going to see them used a lot in many programs out there. We are going to stop here in this lecture. In the next chapter, we are going to start and learn about references. Go ahead and finish up here and meet me there.